Our third unit is going to start with a study of absolute value functions and their graphs. We've done some solving of absolute value equations. Now we're going to look at how their graphs look. So just a quick reminder, if we have something like the y equals the absolute value of x, we need to remember that the absolute value of 3 is 3 and the absolute value of negative 3 is 3. Therefore, you have two different x values giving you the same output, the same y value. So because of that, you're going to end up with a graph that is symmetric about the x-axis, because on the right side of the, about the y-axis, on the right side of the y-axis and the left side of the y-axis, you're going to get the same solutions. Therefore, the graph's going to look the same on both sides. And also, absolute value functions are going to look similar to linear functions, where they have a slope per se, they follow the same pattern of growth, but at some point they're just going to change direction, and that point where they change direction is the point called the vertex, and so we'll be spending some time looking at that. So here we have our parent function, and an interesting teacher I once worked with always used the terminology the mother function, so that way it's just something the kids seem to always remember, is he'd just walk into class and say, oh, we're doing the mother function today. And so everyone seemed to always remember that. The parent function, we use that term simply because everything we do will come from this function. It's our base function, no shifts, no growth has been done upon it. It's just y equals the absolute value of x. So our parent function has a slope of 1 and negative 1, because we said there's a direction change. So as the graph comes in from the left, you notice it's coming in at a slope of negative 1. It hits the point 0, 0, and it turns into a slope of positive 1. And so 0, 0 is called our vertex, because that's the point where there's a direction change. And our slope for our parent function is 1 and negative 1. Let's look at some movements we can do here with our function of our absolute value. Our first one here we're going to look at is a vertical shift. You see our function y equals the absolute value of x plus k. That k value is going to take your parent function and shift it up and down. So we're talking about a value added or subtracted outside of the absolute value. We'll move our function, we'll move our v shape up and down. The slope stays the same in this case because there's no value in front of x, and we'll talk about that in a little bit. But if we look at our example here, y equals the absolute value of x minus 2, you see we keep our slope at 1 and negative 1 because our only shift we have done is a vertical shift. The minus 2 tells us to take our v shape and simply slide it down 2 units. So therefore our vertex is located at the point 0, negative 2. And when you look at the graph, you'll see it looks exactly the same as our parent function. I'm going to shift back to that quickly. You see the exact same shape, the exact same steepness. It simply has a vertex that has been slid down 2 units. Alright, if we can move the graph vertically, we also have to be able to move the graph horizontally. And so you see here our horizontal shift is represented by an h. We have y equals the absolute value of x minus h. Now, hopefully you recognize the difference between our vertical shift and our horizontal shift. Our horizontal shift has been added or subtracted on the inside of the absolute value rather than the outside. Now the h value, we said, is a horizontal shift. It's going to move our graph to the left and to the right. And you'll notice in the equation the sign of h is negative. It's x minus h in the formula. So therefore, that means the shift is always going to go opposite the sign that's given, because the formula is minus. So therefore, if you have a minus, it's actually a positive value for h, so it's a shift to the right. A negative is a shift to the left. I always describe the values inside the absolute value as opposite land. Whatever you see, we're going to do the opposite inside the absolute value. So we'll look at our example here. Y equals the absolute value of x plus 3. Again, the slope hasn't changed. We haven't done any shift with our slope, so we're going to come in at a slope of negative 1 and go out at a slope of 1. And our vertex has been shifted left 3 units because a plus 3, again, the opposite sign always takes over in opposite land. And so we shift to the left 3 units. So if you look at our graph again, it's exactly the same shape as our parent function. The vertex has simply been slid left 3 units. So therefore, an addition or subtraction inside of an absolute value is going to shift left or right however many units are there. Our final shift is our shift in our slope or our steepness of our graph. And that's going to be a number in front of the absolute value, very similar to linear functions. How in a linear function, the number in front of x represents the slope. It's the same idea here. The a value functions as a slope, and it's going to control the steepness of the line. Now, because our graph is a v, you're going to have to apply your slope in two directions. You're going to have to go up and over, but instead of just going up and right, you'll have to make 2 points. You'll have to go up and right and up and left. And then a negative value for a slope will actually take our v and flip it upside down. So we have an example of that here, where we have a function y equals -2 times the absolute value of x. So the slope of our function is going to come in at a slope of +2 and leave at a slope of -2. Now you'll notice we didn't do any shifts inside or outside, added or subtracted to the inside or outside of the absolute value, so therefore our vertex stayed at 0, 0. The negative flips our v upside down, so we just put our point at 0, 0, and then we count down 2 over 1, and we do that in both directions, down 2 over 1 to create that v shape. So that gets us to our standard form. This is all the information that we've gotten on our shifts today. The standard form of the absolute value equation is y equals a times the absolute value of x minus h plus k, where a is the slope, h is the horizontal shift, and remember it's always going to be the opposite the sign that's given to you, and v is the vertical shift. This is probably what you want to have in your notes. Also, you'll notice that you can get the vertex directly from the equation, because the vertex, h is the horizontal shift on the vertex and k is the vertical shift on the vertex. So therefore the point h comma k is going to be the bottom or top of our v. So let's look at an example function of all the shifts. Y equals 3 times the absolute value of x plus 4 minus 1. So we do have a slope shift in this case. Our slope is 3 and -3. We have a horizontal shift, left 4, and a vertical shift, down 1. So that puts our vertex at -4, -1, and you can see on our graph we've placed our vertex there, and our slope is a +3, and so that tells us we're going to go up 3 over 1. But in order to make the V shape, you have to go up 3 right 1 and put a dot, up 3 left 1 and put a dot. So we make a dot on each side, and then we can draw in our V shape. All right, hopefully we don't have any questions. If you do, make sure you ask them in class tomorrow. We'll see you tomorrow.